Hello everyone, welcome back to my channel. Today let's go over a premium hard question in the database/pandas category that I just solved on my own. So I'm really glad that I was able to come up with my own solution to this problem without any help. And I thought it was pretty straightforward. So let me show you how I did it. This one's called Maximize Items number 3052. And basically what they want you to do is to return prime eligible and non-prime eligible in terms of the number of prime items you can stock. So you have this limit 500,000 and you're going to try to stock as many primes as possible and then as many non-primes. So this is basically how many items you can stock. And what you'll notice is, for example, we want to get all the prime eligibles. And then if you look at the examples, we want to sum that up. Okay, if you follow this explanation, it's actually really easy. That's what I did. And then now you can have 555. You know your overall limit is 500,000. So try to find the biggest number when you multiply it with 555 that's not over 500,000. That happens to be 900. And then the rest is just simple math because there's only one solution. I mean, after you're left over, the non-prime is what it is. So that's it. And let's go ahead and implement it. Let me show you how I did it. Basically, now let's just focus on getting all the prime eligible items and their square footage. So we don't actually care about the item ID. Let's go ahead and declare a default dict of type list for IV in enumerate inventory. Let's do square footage. So if this is a prime eligible, so if inventory prime eligible, inventory square footage. Wait, what am I doing? Inventory item type of I is equal to prime eligible. In that case, we would basically, let's just go ahead and call this P. Okay, we want to append the square footage. So let's append V. It's either prime or not prime. So otherwise, if it's not, then let's just call this NP for no prime, dot append V. Okay, so now if we loop over the dictionary, we now care about the sum, right? So the prime sum, let's go ahead and call this total. So we don't even care about this because first of all, we want to take care of all the primes first. Just follow what this says. So now we can just say total prime is just going to be sum of D of P. Okay, I think there has to be a prime and a non-prime here. There's no edge case there, so that makes it a little easier. And let's go ahead and print tot prime. Cool, so 555.2. Now what we want to do is loop to, let's say, a very big number, 10,000, 100,000, and we want to ask if tot prime times I is bigger than 500,000. So let's call this allowance 500,000 allowance. If that's the case, then we can print I and break because that's the first one. It's not, that's invalid. That's bigger than 500,000, right? So we can't stock that many primes. So we can stock 900 because that's the one right before it, right? It can be equal to, but it, because non-prime can be 0 as it says right here, if it is. So, and then we can just say the prime count is going to be float of negative infinity because we just want to record this number. So p count is equal to I minus 1 and then break. Okay, so if primary count is not equal to float of infinity or negative infinity, then let's go ahead and print PC. So that should be 900. Not equal to Okay, so now that we have 900, what we want to do is, so how do we get this 5400? Well, we want to use the length times this 900 number. So PE, let's just call that because that's the actual value, is length of D of P times PC. So let's print PE. Cool, so 5400, and then also remember we want to subtract it, so let's call this allowance. We want to say allowance. In that case, we can say allowance minus equal to what it was. So 555. So total prime times PC, right? And let's print allowance. That should give us a smaller number. Cool. So now we have 319, 320. So we actually want to round this. Let's call this round. Just want to copy it. Okay, cool. So now this is everything we have for the non-prime items, right? We already did the calculation on the primes. We find this number. Whatever number is going to be the tipping point, and then we multiply it with the length of how many items were in the prime category, prime eligible category, and then we subtract that number from the total allowance. And then no prime now is pretty straightforward. So non-prime is sum of DNP. So again, 10,000. If non-prime times I is bigger than allowance, same thing. Let's call this NPP, whatever you want to call it. NPP is equal to I minus 1, and then break, right? So if NPP is not equal to float negative infinity, we know we found a solution. So in that case, we can just say we want to print NPP. So we got 2 that lines up with this number here. So again, we want to multiply it with the length. So NPP, or let's not P, is equal to NPP times length of D NP, right? So here it's going to be NP. Let's print no, not P. Cool. So 8 and 5400. Awesome. So now that basically gives us our answer. And yeah, so let's just go ahead and categorize it. Let's go ahead and say answer. Let's make this a dictionary. Let's actually put this above here, because we're just going to say, if we found that answer, then we're going to say answer of prime eligible is equal to PE, and then answer not prime, just following this, is equal to not P. So if we print answer, cool, now we're done, and we just have to, last but not least, final, get everything, and then sort it. So for A and answer, final.append A and answer of A. And then sort it, key equals lambda, x, x1, because we're sorting by this in reverse order, biggest to smallest. Let's print final. It's not a good practice. I know Java, that's a keyword. Okay, cool. So now we can just unpack it, right? So for F and final, we basically have our solution, just return a data frame. So PDD, return that. 1, 2, standard list. F0, first column. F1, second column. And then PDD prime eligible is equal to 1. PDD prime not prime is equal to 2. Okay, let's run this. Okay, that's not right. Oh, that's weird. Oh, it's item type. Item count. Okay, that's final one. Yep, so this goes first. Did we define F somewhere else? Or maybe one. You messed that up. Okay, cool. So let's submit it. And there you go, passes all test cases. Again, I'm really glad that I was able to come up with my own solution to this problem without any assistance and solve it on my own. So that's it for this video. Thank you for watching and stay tuned for more.